Question 1. R and L represent respective resistance and self-inductance. Which of the following combination has the dimension of frequency? Now resistance is V by I and inductance is Vt by I. So the combination R by L would be equal to V by I divided by Vt by I, which will be equal to 1 by T, which is nothing but frequency. So the combination R by L would be the correct option. Question 2. The unit of self-inductance of a coil is? The unit of self-inductance of a coil is Henry. Option B. Question 3. Displacement x of a particle is related to time t as x equals at plus bt square minus ct cube, where a, b, c are constants of the motion. The velocity of the particle when its acceleration is 0 is given by. Now here I know x equals at plus bt square minus ct cube. Velocity would be differentiating x, I would get a plus 2bt minus 3ct square. Same way acceleration would be 2b minus 6ct. Since we know acceleration is 0, we would get t equals b by 3c. So substituting t equals b by 3c in velocity equation, I would get v equals to a plus b square by 3c. So your correct answer would be option C. Question 4. A large number of bullets are fired in all directions with same speed. What is the maximum area on the ground on which these bullets will spread? Now the bullets are fired in all directions. So all direction would mean the figure would look like a circle. So area of circle would be pi r square. So the bullets are spread in a circle, hence the area in which the bullets are spread is pi r square. Now for maximum area, I will have r would be equal to r max. So therefore I would get r max equals to v square by g. So maximum area is pi r max square, which would be equal to pi v square by g the whole square, which is pi v raised to 4 divided by g square. So your correct answer would be option B. Question 5. The relationship between the time of flight of a projectile Tf and the time to reach maximum height Tm is. Time to reach maximum height is Tm. Same way time to reach back to the ground would also be Tm. So max height and back to ground, both would be Tm. So the time of flight would be time to reach maximum height plus the time to reach back to ground, that will be 2 Tm. So Tf would be equal to 2 times Tm, that is option A. Question 6. A person of mass 60 kg is inside a lift of mass 940 kg and presses the button 1 control panel. The lift starts moving upwards with an acceleration 1 meter per second square. If g is equal to 10 meters per second square, the tension in the supporting cable would be. The tension in the supporting cable would be the mass of the lift plus mass of the person multiplied by g plus a. Since the lift is moving upwards and gravity is downwards, so the resultant acceleration would be g plus a. So I would have 940 plus 60 multiplied by 10 plus 1, that will be 1000 divided by 11, sorry, 1000 multiplied by 11. So which should be equal to 11,000 Newton. Option D. Question 7. A player caught a cricket ball of mass 150 gram moving at the rate of 20 meters per second. If the catching process be completed in 0.1 second, the force of blow exerted by the ball on the hands of the player would be. Now we know force is nothing but m u minus v divided by t. So mass of the cricket ball is 150 gram moving at the rate of 20, that is basically initial speed is 20 meters per second, and since the person is catching the ball, the final speed will be 0, so it will be 0.15 multiplied by 20 minus 0 divided by 0.1. So your final answer would be 30 Newton. Question 8. A neutron moving with a velocity v collides with a stationary alpha particle. The velocity of the neutron after collision will be. Now, neutron moving with a velocity v collides with a stationary alpha particle. The velocity of the neutron is what we're supposed to find. So, velocity of the neutron would be m1 minus m2 divided by m1 plus m2 multiplied by v. Now m1, m2, m are basically your mass of neutron and the mass of the alpha particle. Mass of neutron is approximately 1, mass of alpha particle is 4, 1 minus 4 divided by 1 plus 4, approximately this would be minus 3 v by 5. That is option A. Question 9. Two balls each of mass m are placed on vertices A and B of an equilateral triangle of ABC of side 1 meter. A ball of mass 2 meters is placed at vertex C. The center of mass of the system from vertex A located at the origin is. So here it says vertex A is located at the origin, so 0 is the coordinate of vertex A, x and y coordinate. B would be 1, 0, and C, since this is an equilateral triangle, C, the x coordinate will be half and the y coordinate would be nothing but the height of the equilateral triangle, which is root 3 by 2. The mass kept at point C is 2m, at A it is m and at B it is m. The sides are 1 meters each. Now center of mass of the system from vertex A is located at. So basically I need to find the coordinates of the center of mass. So center of mass coordinates to calculate, I would have x coordinate would be equal to m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3, where m1, m2, m3 are masses, x1, x2, x3 are the coordinates of points A, B and x coordinates of point A, B and C. On substituting, I would get this as half m. Same way y would be m1 y1 plus m2 y2 plus m3 y3 divided by m1 plus m2 plus m3. Again, on substituting all the values, you would get the answer as root 3 by 4 m. So your correct answer is option C. Question 10. A solid cylinder of mass 2 kg and radius 0.2 meters is rotating about its own axis without friction with angular velocity of 3 radians per second. Angular moment of the cylinder is. Angular moment is given by L equals to I omega, which will be equal to half m r square multiplied by omega. Now in this case, half mass is given as 2 kg, radius is given as 0.2 and omega is given as 3. So on solving this, I would get 0.12 joules second as the answer, which would be option C. Question 11. The angular velocity of rotation of star of mass m and radius r at which the matter start to escape from its equator will be. So, since the matter has to escape from its equator, so basically it would be the escape velocity that we're talking about here. So escape velocity would be equal to VE equals root of 2 gm divided by r. If star rotates with an angular velocity omega, the angular velocity would be V by r. So in this case VE by r, which will be equal to 1 by r root of 2 gm divided by r, which would be equal to root of 2 gm divided by r cube. So your correct answer is option C. Question 12. Forces of 100 Newton each are applied in opposite direction of the upper and lower faces of a cube of side 20 cm. The upper face is shifted parallel to itself by 0.25 cm. If the side of the cube were 10 cm, then the displacement would be. So when the side was 20 cm, the displacement was 0.25 cm. Now we know eta is FL divided by A delta L. From here I can say that is equals to FL divided by L square delta L, which equals F divided by L delta L. So from here I can say delta L is nothing but inversely proportional to L. That is, higher the length of the side of the cube, lower is the displacement. So in this case, initial length was 20 cm and it got halved to 10 cm. So automatically the displacement, which was 0.25 cm, would now double to 0.5 cm. So your answer would be option B. Question 13. Two solids A and B float in water. It is observed that A floats with half of its body immersed in water and B floats with 1/4 of its volume above the water level. The ratio of density of A to that of B is. So for A, half its volume is above water and half its volume is below water. So for A, I would have VA divided by 2, that is half its volume is below water, density of water into G, that would be the upthrust, which would be equal to VA multiplied by density of air multiplied by G. So basically I get density of air equals density of water by 2. For B, 3/4 of its volume is inside water and 1/4 is above water. So 3/4 of VB multiplied by density of water multiplied by G would be equal to VB multiplied by density of B multiplied by G. So density of B would be equal to 3/4 density of water. So density of A divided by density of B would be equal to, taking the ratios, 2 by 3. So 2 by 3 would be the correct answer. Question 14. Two very wide parallel glass plates are held vertically at a small separation R and dipped in water of surface tension S. Some water climbs up in the gap between the plates. If P0 is the atmospheric pressure, then the pressure of water just below the water surface in the region between the two plates is. Here, the free liquid surface between the plates will be cylindrical, which is curved along one axis, that is parallel to the plates. The radius of curvature of meniscus r would be equal to small r by 2. Now for cylindrical surface, P0 minus P equals to S by R, that is capital R. This capital R is nothing but small r by 2, so it becomes S by small r by 2, which is equals to 2S, basically 2S by small r. So I would have P0, P would be equal to P0 minus 2S by R. So option A would be your correct answer. Question 15. On the Celsius scale, the absolute zero of temperature is at. On the Celsius scale, the absolute zero of temperature is at minus 273.15 degrees Celsius, that is option D. Question 16. First law of thermodynamics is given by. So which of the formula basically represents first law of thermodynamics? That is actually option A is the correct answer. Delta Q equals delta U plus P delta V. So in that form I would have that dQ equals du plus P dV. Question 17. 4 engines are working between the given temperature ranges given below. For which temperature range the efficiency is maximum? Now I know efficiency equals 1 minus T2 by T1, which will be equal to T1 minus T2 divided by T1. In all 4 cases, T1 minus T2 equals 20K. That is basically difference between both the temperatures is 20K, 20 Kelvin. So for efficiency to be maximum, T1 has to be the lowest. So out of the 4, T1 is lowest in case of option B, that is 40K. So efficiency would be maximum in case of option B. Question 18. 1 liter of oxygen at a pressure of 1 atmosphere and 2 liters of nitrogen at a pressure of 0.5 atmosphere are introduced into a vessel of volume 1 liter. If there is no change in temperature, the final pressure of the mixture of the gas is. Now, according to ideal gas equation, I have PV equals to nRT. For oxygen, P is given as 1 atm, your volume is given as 1 liter. So I would have an N equals to your number of moles of oxygen. Therefore, this equation would become NO2 would be equal to 1 by RT. Same way, for nitrogen, P is 0.5, volume is 2 liters, and N would be equal to N, capital N. So your number of moles of nitrogen would be equal to 1 by RT again. So number of moles of oxygen equals to 1 by RT and number of moles of nitrogen is equals to 1 by RT for this mixture of gas. Now since we know number of moles of the total mixture will be number of moles of oxygen plus number of moles of nitrogen, so I would have N mix equals to NO2 plus N2. And the pressure of the mixture into the volume of the mixture would be equal to number of moles of the mixture into R into T. So basically, pressure of mixture into volume of mixture divided by RT is equals to 1 by RT plus 1 by RT, which is equals to 2 by RT. So I would have pressure of mixture into volume of mixture equals to 2. So I would say that the correct answer in this case, which is asking for if there is no change in temperature, the final pressure of the mixture of gas is, now since if I take volume as 1 liter, volume of the mixture as 1 liter, then pressure would become 2 liters, 2 atmospheres. Question 19. Out of the following function representing motion of a particle, which represents SHM? Y equals sine omega t minus cos omega t, y equals sine cube omega t, y equals 5 cos 3 pi by 4 minus 3 omega t, y equals 1 plus omega t plus omega square t square. So for SHM, in order to, for any of these equations to represent SHM, I should have d square y by dx square by dt square proportional to minus y. So on solving the equation, that is differentiating this equation twice, I should get them to be proportional to minus y. Then only it would be representing an SHM. So in this case, after solving this, you would get 1 and third. The first one and the third one will be the only two equations. That is, this and this would be the only two equations to represent an SHM. The correct answer would be option D, only 1 and 3. Question 20. If the displacement equation of a particle be represented by y equals a sine pt plus b cos pt, the particle executes. Now I have y equals to a sine pt plus b cos pt, where let a be r cos t theta and b be r sin theta. On substituting this, I would get y equals r sin pt plus theta, which basically represents the equation of SHM. So question 20, the answer would be SHM. Question 21. The fundamental frequency of a sonometer wire is V. If its radius is double and its tension becomes half, the material of the wire remains the same. The new fundamental frequency would be. Now for a sonometer, the fundamental frequency is directly proportional to root T and inversely proportional to R, radius. So I would have V1 by V2 equals to root of T1 by T2 multiplied by R2 by R1. Now I know R2 is 2 times R1 and T2 is T1 by 2. On substituting, I would get V1 by V2 equals to root 2 multiplied by 2. So basically V2 would be equal to V divided by 2 root 2. So your correct answer would be option D. Question 22. Let EA be the electric field due to a dipole in its axial plane, and let EQ be the electric field in the equatorial plane. Then the relationship between EA and EQ will be. Now for a dipole in a axial plane, EA is given by 1 upon 4 pi epsilon 0 to P, that is a dipole moment, N by R cube C. Whereas EQ, in case of an equatorial plane, when the dipole is in the equatorial plane, the equation becomes 1 upon 4 pi epsilon 0 P N by R cube C. So using both the equation, I can say EA by EQ would be equal to 2 by 1. So EA would be equal to 2 times EQ. So your correct answer would be option C, EA equals 2 times EQ. Question 23. 6 charges, 3 positive and 3 negative of equal magnitude, are to be placed at the vertices of a regular hexagon such that the electric field at O is double the electric field when only one positive charge of same magnitude is placed at R. Which of the following arrangements of charges is possible for P, Q, R, S, T and U respectively? Now here when we look at option D, for P and S, the electric field will be 0. For Q and T, again the electric field would be 0. For R and U, that is R positive, U negative, the electric field will be added up. Hence the correct option is option D. Question 24. An air parallel plate capacitor has capacity C. The capacity and distance between the plates are doubled when immersed in liquid, then dielectric constant of the liquid is. Now in first case, when the dielectric is air, C would be equal to epsilon 0 A by D. In second case, C dash will be equal to K epsilon 0 A dash by T dash. Now distance between the plates is doubled, capacity is doubled, area remains the same. So this becomes 2C equals K epsilon 0 A by 2D. So 4C would be equal to K epsilon 0 A by D. Epsilon 0 A by D is nothing but C itself. So this will become Kc. So your K would be equal to 4. Question 25. In the given circuit with steady current, the potential drop across the capacitor must be. Now in the given circuit, moving, let this point be point A and let us move anti-clockwise from point A. Let the current in the circuit be I. So I would have minus I R